Hello and welcome to the 3D concrete competition. We are happy to see you here, and this is our last theoretic meetup before the finals. We will have one presentation meeting next Tuesday in University of Latvia, where each team will be able to try their presentations on pitch meeting, but otherwise it's been a very long journey, which I will quickly demonstrate to you. To get here, we had a lot of theoretical meetups, we had several practical meetups, and we should probably also thank all our guest lecturers and sponsors, which all can be seen on the Miro board here. But this evening, we also have a very special guest, which we will introduce very shortly, while I see that some more people are joining. So for those of you who are first time here, just a few words about concrete competition in general. All started in November of last year when we started with some 3D modeling meetups, actually it's October. And then we proceeded with Mari's lecture on concrete printing and opened the competition. On the competition, we had several teams which participated with their ideas. Also, as you can see, we got a pizza competition. So also some non-formal activities. From those teams, we selected the 10 best that continued work for 3 months. I think probably a bit more if we count all the weeks. And that led us here to the last lecture probably, and also to the posters and exhibition in University of Latvia. So if you are thinking when we can see the final presentations and posters, the date and location is 1st of April at University of Latvia. And if you are looking for the Facebook event, it looks like this. And it starts at 4 o'clock. I would suggest arriving a little bit earlier. Otherwise, without a lot of further ado, we can welcome with applause today's lecturer, Eva Zene from Socrates Research and Development Department. I guess if I mistook, then you can correct me. Welcome, Zene.
Yeah, it's correct, Matti. So my name is Eva Zene. I'm working in Socrates as Research and Development Manager, as Matti's already told. And I will tell you this evening a little bit how the dry 3D print dry mix is development and why we had idea to start to do something like this, which is completely new and a lot of is talking and but not yet in Baltics like home where we can live is printed out. So we hope that in few years it will become true and we can really live or somebody can try to live in 3D printed house in the Baltics. So let's start with the presentation.
For participants who are looking the presentation later, all the presentations are also on the Miro board, so you can later, if you forget something, you can definitely find it there. And also, if you have any questions at any point for Eva, you can type them in the comment section, and we will read them later, or you can also raise your hand, and then we'll give you a chance to ask. If you are watching this lecture later, then you unfortunately don't have an option to ask a question anymore, but you can come to the final presentation, and maybe Eva will be there. We'll see. We'll definitely send an invitation to her.
Yeah, I have also scheduled to be there, and you can
Awesome.
always send me the email or reach me in the other ways. I'm always open to answer the questions. So some small.
Yeah, we can see everything. You have to click in the screen and then it should work.
Oh, okay. Okay, so small introduction about Socrates itself. So what it is, it comes from the word "sac" and concrete, and when you put them together, it becomes a Socrates. It's actually the founded was actually in U.S. in America in States. Currently, we are like renting the franchise from the Socrates Germany group. But Socrates in Baltics, let's say, was founded in 2003, and it's 100% owned by Latvian citizens. So yeah, there also in the graph you can see in the turnover from very small we jump to the huge one, and we hope to continue to see these growing peaks. But well, let's see. Nowadays in the world there is happening a lot of things. So we don't know how it will continue. So what we have as a Sacred Baltics, we have the uh, 4 plants, I would say, in Riga. We have one dry mix plant and one ready mix material plant, which means paints and everything what you can use. You just open the bucket and you can use. It was founded in 2004 and 2006. We have also the plant in Estonia, in middle of Estonia and Paide. It was started up in 2007, and we have the plant also in Kėdainiai in Lithuania, which was started in 2008. Um, uh, then of course what we do also some exports, but you have to understand that our product is quite heavy, and so it's very expensive if you move it far away. That's why we have some exports, but not that much. It's basically the Baltic market, but also we sell some volumes to Finland, Sweden, and then Denmark, and sometimes to some exotic like Iceland and some Qatar and things like that. But that's more exotic, not the regular thing. What Socrates is producing? We produce more than, I would say, more than 200 products different. It's like concrete masonry mortars, plasters, different tile adhesives, self-leveling and leveling floors, concrete repair and construction system products, different historical mortars and plasters. Uh, we have huge market of heat isolation system in Baltics, primers and buildings, paints, fillers. I think everything what you can when you go in big supermarkets like Depot or Kurshi, you can find all our products. So then we produce also some products under the other brands like Masterline, Havek, Baurok, and others. We offer several services like silo rental. If you don't want to buy in a paper sack, you can rent a silo which is full of the material from us. Be cement packing, we are doing cement packing and distribution. We do the paint and plaster tinting in our plants, and distributing some other materials in the Baltics. And then how the, let's say, dry mix development process is going on in total. Everything always starts with idea, and then it goes with recipe development in the laboratory, testing in a construction place. In the same time, you are working and looking for the raw materials, and then it turns several times round and round, and suddenly you understand that your product is ready, and then you jump to the next part, which lays all the product certification, documentation, preparation, marketing in the same time, and then in the end you are very happy because you can start to sell and sales grow up. Um, how from where those ideas is coming, and these ideas are coming from a lot of places. I will show you some where it comes in our case, but I think in the most of the cases it's like this. These are, sales managers. They are coming with ideas about, popular products in the market, fashion products. Sometimes builders are requesting some special products. It comes also from the R&D managers and technologists. They are doing some jobs in lab and they found some good things, and they know that it can be used later on as an extra product. Raw material suppliers, nowadays they are also developing new raw materials and they are coming with them, and of course then we are forced to think where we can use it, because sometimes those ideas is good. Then of course very popular it was, and I think it become even more popular in last months is, let's say, green ideas, so European Green Deal with CO2 emissions. Everybody is forced to think how to produce your products with less CO2 emissions, products which are more friendly to the more friendly to environment. Also, in a lot of cases, standard requirements, just they change the standards and you need to adapt to them. Then, of course, it's universities. It's also, they are also doing the good scientific discoveries, and it if we see that that can be um, produce it in our plant and sell in very well, then we can adapt that one. And of course, there are a lot of more places from where these ideas are coming usually. So where we got the 3D print mix idea. So what we saw some very fancy houses, very fashioned ones. So we thought it looks nice. We would like to do something similar. Of course, our technologies in the laptop looks like that we can do also the dry mix. Seems that we are capable to do that. We analyze at what raw materials we have. Do we have everything what we need for such a dry mix print? And it seems okay. And and then we know that Rigas Technical University is having kind of 3D printer, which is not really used. And and then we also, of course, looked on some industry top magazines. So we saw that those articles about 3D printing are quite a lot of in each of the magazine, and it's becoming more and more popular. As you can see, the curves are going up and growing up. And but then we stopped at the one point. We understood we have everything. We have technologies, we have the raw materials, we have plant where we can produce. We have 20 years experience in market, in dry mix market. But what we cannot do, we cannot test the product. And one of the very important part when you do the new product is testing in real field. Testing in the lab is okay, of course, we have also the application technologies which are testing our products in real place, some plasters or tile adhesives, but we cannot test the 3D print mix because we don't have the printer and we do not do the business with such a things with printer. We don't have the IT specialists, we don't have the mechanics. Then we started to talk with Rigas Technical University. They were interested with that. And the last year in April, we officially opened the Socrates 3D concrete printing laboratory, and it worked successfully all this year. All the last, let's say, the last year and continue this year. They had already the frame time printer. I think Maris already told you several times about that one. And then we were ready to take the industrial doctor who will work with us to test our material. So inside of the Rigas Technical University, we are working together with Maris Shinka, which is the head of laboratory. I think you have seen him already several times in these Tuesday presentations. Also, we have this industrial doctor, which is like Socrates industrial doctor, Chris Zemelis. Most probably you have seen also him. And then some for some resting minutes.
Mm.
Do we hear the sound?
We need to share with sound to hear the sound, but we can see the video. If you want to share the sound, you have to stop
I
screen
think it's
sharing,
okay.
start. Yeah, I think it's fine. It's
Just
a good reason to visit your company's profile and see it in the in the local, yeah, and like it, and then like
yeah,
comment.
this
Yeah.
was yeah the nice short TikTok video. Um, then of course, okay, it's clear about the idea from where it comes. We understand what we are missing. We get it what we were missing, and then it starts the recipe development in the laboratory. In the same time, we are working a lot with the raw material findings. So we need to understand what we have, what we need. So it's hard work with material suppliers, not only with Latvian, but also the material suppliers abroad. We are buying our raw materials from all over the world. And so then to find the right one is not really the problem. And then when you imagine the laboratory, then usually you think that it's kind of the fancy place where the crazy chemists do explosions. But in reality, when you go in dry mix laboratory, it's kind of serious place where you do the hard work. So what we have 4 laboratories in Sacred Baltic, 3 dry mix, 1 polymer-based materials, 2 labs is in Latvia, 1 in Estonia, 1 in Lithuania. What we do there the R&D for the products and also the process control because we are also producing every single day. We have 8 to 10 chemical technologists who are working in those labs. And Socrates is having more than 20 years experience in R&D. If we talk about 3D prints, 3D mix, dry mix recipe, then I can say that 95% it's domestic raw materials and that we are using the Latvian raw materials, which is good from the CO2 emission point because you don't need to move them far away from China, for example. Some part are of course coming from abroad because Latvia do not have such an industry to give for us all the raw materials. Then what would you do? You do the laboratory testing for the dry mix which you put together. So you do the material granulometric, which is very important. Then you look for the wet material working properties, and you can see very well how it goes step by step. Then, of course, it's like wet material flowability, which is very important when you do the 3D printing print, because if it doesn't flow, then the printing wouldn't be successful. Of course, you need to always dose the right water amount. If you put too much or too less, then also nothing good will happen in the end. Then in a lab, one of the most important factor is material compressive and flexure strength because that would say how strong will be your house or what kind of the house you can build. And it looks like this. You made the prisms and you broke them. Of course, you can make also the cube. It depends what kind of the technical properties is in each laboratory. Then at a certain point, you feel in a lab or technologists feel in a lab that material is ready, but they are not sure if we really can print it out. It's what I told you in the beginning that we need to test in a site. So this on-site testing is Riga's Technical University lab, and then they start to test. And they start to test, and usually after the first testing, they are screaming, or the on-site testings are screaming that nothing good, that everything is bad. Then you start to look what is bad. Sometimes just on site you use it on the wrong way. Sometimes really you need to develop more the recipe, to change something in recipe. And those recipe changing and again testing on site sometimes can be 10 times, sometimes 3, sometimes maybe 20 times, depends. So this is how it is tested on Riga's Technical University. And then at a certain point they are happy and say, this recipe looks good. We can print out something and we can work with that. And with 3D printing, the hardest part is the printing. Because if you do not do, or you do not know how to do the right printing, then we can give the perfect material and you are not able to print it out. And then those rounds are finished, the cycle is closed, and then start the next part, which is also very important, is product certification and documentation preparation. In the same time, usually you do the marketing things. You already start to think how you offer each product in the market. And then If we talk about 3D print material, there is the one quite big issue about what we do not think yet, or we think but we do not do nothing. Um, Usually for dry mix, you write some technical data which customer can use on site. Sometimes if the product is under the harmonized standard, you get the CE mark, you do the certification. But for 3D at the moment there are no standards, which is kind of the problem. Because if there is no standard, then also for us it's actually quite challenging to develop the recipe for the product which does not have the standard. We have now developed the recipe, but at the moment we are not sure if that material fits in any standard. If you want to build a house where the people can live inside safely and all the institutions approve that, then it's not that easy at the moment. It is possible, but it's really huge work. What we are hoping that at one point there will be some kind designer guidelines. Architects would know what kind of elements are possible to print, because not everything what architects can imagine afterwards can be printed out on site. Um, So I think this will be the next very big step, which Europe or worldwide will be started to write kind of the standards for 3D mix. Um, then, of course, when all the documentation, as I told you, is ready, you go for the marketing activities. Um, I think already the people in Baltics who wanted to know about 3D printing is well informed what's happening in Rigas Technical University. Also, this competition, I think it's quite popular and everybody knows about that. And then when one day when we will have all the standards, and we will have printed out several houses with our 3D mix print material, we can say that we can start the product successful sale. So that was shortly about raw mix development. Of course, every dry mix company's recipe is like their own know-how. Of course, we wouldn't share that one with everybody. That's more or less clear. But yeah, maybe then you have some questions if somebody.
I really liked how you showed the process of testing and re-evaluating works in the development of material, because for our team students had to develop the prototypes, and it also took a lot of testing, because first we tried it in plastics and then we tried to print some examples, and then every stage and iteration there were some corrections from real life. So maybe the opening question would be, what changes were from real life scenarios that impacted your material structure? Did it change from testing? Because you, for example, in the lab came up with a formula, and what were the effects that you didn't plan for? Or maybe your planning process is that good that you didn't need to make adjustments.
No, no, not really. Of course, not really. Of course, we have before we started with Rigas Technical University cooperation. We have tried in some other places, and we already knew something. I think the one of the most important thing, which quite often is different than the labs thing, is a water amount which you need to dose. um, because we were recommended the one water amount, but then in real life actually was needed to add another one. I think that was the most important thing. Of course, there is always discussion about the granulometric size of each material, um, which need to which need to be compatible with the printer head. Um, we would like maybe to have that there is stones inside 8 millimeters, for example,
Hmm.
which is not possible with the current printer what we have in Rigas Technical University, for example, or we would like to add some some, or we would like to add something less, because there are some things which are of course improving the flowability, opening time, the structure itself, how it holds together when you start to print layer to layer. But I think then when you do the real printing, then we saw what we need to really add and how much we need to adjust each parameter. I would say that we are having the big experience, and some of our technologists is working more than 10 years, and they are having the quite good feeling what each material needs.
Mhm,
As the 3D printing also is done through the um, kind of plastering machine, let's say,
mhm.
then we had those also the plaster product, so we knew already what we need, that material can flow good through all the machines and the systems. But of course 3D printing is having their own challenges, and I think we do not know yet all the challenges. There need to be also tested the frost resistance and compressive strength, which is also quite challenging. We do in a lab like regular standard test, but when you do the printing, it's a little bit different. And all those things hopefully will be brighted in the standards how it has to be done, because at the moment it's just our experience, or our how we used to do. We did also the 3D print material. If it's correct or not, it's I think nobody can tell us at the moment
Yeah,
yet.
it will take 30 years, right, to see the first
I hope
house.
not. I hope not.
Well, yeah, some people living in the house, then seeing how it ages and then all that. But of course, some.
Sometimes it's like that. I hope that maybe next 10 years they will write some norms, and of course then these norms will be changed, because when you start to use in your real life, then you find out that that is not working and that is not working. But 30 years is too much, I think.
Yeah, let's hope for 3 years. That would be a great goal for 2025. So we have a few more prepared questions. Otherwise, all the participants that are here right now in the Zoom meeting, you can write the comments in the comment section or raise the hand, and then you can ask a question verbally, or you can try to comment on Facebook. Maybe we will see it, or we will forward the question later. The question I had is that I really liked the. Oh, that's just a comment. The question will follow that this way of producing the material came from market research, that you actually saw that there is demand already for like, or at least there are a lot of research going on, and you followed it, and it's really interesting to see that. The thing that caught my attention is you said plastering machine. Are they being used in Latvia too,
Yeah, this how
like
do you
robots that plaster the walls,
no,
or is it?
it's not a robot. The thing, what is already widely used also in Latvia is the machine which mixes the plaster, and
Mm-hmm.
then how it's not a robot who is putting there is a people who is putting in on the wall.
But it supplies of steady flow of
It's supplies of steady flow. Yeah, it's supplies of steady flow. It mixes with the water in a machine, and
Mhm.
actually we use the same for 3D printing at the moment.
Oh, perfect.
I haven't seen
That
nothing
was the
else.
interesting thing, how you take experience from one sector and apply it to the next, and it's really interesting. And then you arrive at a printed house at one point, but it's not like one day. It's interesting that there are always historic solutions that lead to that.
Yes, but I think usually it more or less goes like that. Then you adapt something to something, and then maybe in the end there will be specially designed this mixer which is giving you steady flow when you do the printing. But I think what I have seen so far worldwide, that everybody is using this plastering, or sometimes there are also the similar machines when you do the some floor castings.
Mhm.
Depend. These machines are different, but they do the same job. They just give you a steady flow, all of them.
Okay, we have one more question that you mentioned Iceland during the presentation as an exotic location where some concrete, no, but the dry mix gets shipped. A question here is, do you project that these 3D printable dry mixes will have more probably marketability in wider, at least Baltics or Europe, as they are, not they will be more transported because not that much companies will, or do you see it as a market that it's evolving very quickly and there is already a lot of competition? How do you see the sector in the next few 10 years in regards to, do you see a lot of companies competing with these 3D printable materials? Because for plastics, for example, you do have some established brands, and then there are a lot of these kind of knockoff brands that you can get, and no one guarantees that it will hold up. But in construction, of course, you need the certifications, etc. But still, concrete also, a lot of people mix concrete on their own. So maybe like this is, of course, it depends on scale and a lot, etc. But it does feel like a wild west a little bit currently in this market. And maybe like if you have some prognosis, what you see will be like the next 10 years in this.
No, I think that in next year, almost all the dry mix company who are really working on research and development will be able to produce this mix for 3D printing. It just depends if we just want to be ready when really this become as a fact that we are starting to print houses in the, I don't know, Latvia, Lithuania, Estonia, and Baltics, or in some closer countries, that we already know what is it and what kind of material the customer is asking. If we would wait those 10 years and only um, then start think what they need, or start to do when only they have already the need, then somebody wants to print, I don't know, kind of the big house in center in Riga, and they are asking us material, and we start to think, oh, what can be inside in this material. It's too late. It's far too late, because you need to be ready with that, and you need to know all what it's not only the dry mix. We can give the dry mix, and but if the company doesn't have any skills how to do the printing, nothing will happen. Or or also for us, it's important where the printing process can file. Of course, we will never do the printing itself. We are not a company who will. We're not a construction company. Let's say we are just producing the construction materials. But what we always do, we always try to be very skilled also in construction, because if the customer do something wrong, then of course they say that the material is guilty, and
Of course.
we need to have the right technologies to be able to understand if it's material or it's a customer fault. And if you do not understand how the printing works and where it files, then we are screwed. Then we are always guilty. Then nobody will buy from us. And it's not only with 3D print material. It's all with all our materials. We need to know the basics, how the material is used on the construction place. It was the same with the 3D print material. Our technologists in the labs, before they started to work with the recipe, they were watching the videos. They were trying to understand what are the mm, places, or what are the properties, what is needed for such a material, and why, and where it can fail in the printing process. Where are the bottlenecks about what we as a dry mix producer need to think then in order to get easier printing process for the builders. If we wait to 10 years, then we are too late.
Okay.
Also very important thing, I think, was that we see that the Germans are doing, the others are doing, and if we do not do nothing at the moment in Latvia, then we are a little bit too late. Then the others will start to print, and we won't be ready for that. Our architects, designers, builders, they wouldn't have any knowledge about that, how to do that. Of course, there are the international companies which are in Germany and which are in Latvia, and they can transfer the skills to Latvia, which is good. Um, Also, we have to understand that the dry mix, 3D print dry mix is heavy, like all our materials, and it will be always economically better if they do the printing in Latvia, then they buy also the material produced in Latvia. They can always get it from Germany to Latvia, of course, or from other country, France or Denmark, but it will be expensive.
Understood. Yeah, there's a question from Rayar. Will certification process for 3D printing material plan to be in relation to specific printer on which tests will be made? So I think, is the material usable on any printer or is it printer specific?
That's a good question. That's a good question, and so far I haven't found the answer because it's true that each printer can have the different needs. Uh, but if I'm looking on the industry in general, then usually you do not certify the material for the for example the mortar. Let's take the mortar, which everybody knows. The mortar you can use for bricks. You can use for aerated blocks. You can use for some different bricks. You know, the bigger one, the smaller one. But the mortar standard is the same. So I think the standard will be written for in general for 3D printing, and then you can choose the right how to say the right material for your printer. But it's that because then how we separate the printers. Okay, there are some separation possible, but don't think so. I think it will be written in general, and then printers can be different. But I think in the end there'll be like three most popular kind of the printers which will be printing. Maybe I'm wrong, but usually it's like that. For each printer, own material, no, don't think so.
Okay. A question follow-upping this one is the certification, of course, will take some time also for construction boards to follow through. In one of the previous lectures from Ferry, when they showed how they did it in Germany, they said that they just tested everything. And in some ways, it was even easier because then they just went for everything, right? And they didn't have to kind of try to fit in together different certification approaches. They just did everything as a building that gets fully tested for strength. But for the furniture and especially this competition, we are doing a bench. Do you see this solution for the few following years as being widely used, maybe, or at least at first, as a easy to apply solution for custom outdoor furniture, or for example, public spaces, etc.? Is this something that you probably have seen elsewhere? Is this a viable approach while we are working on building printing the buildings?
I think yes. I think yes, and that was also what we were discussing a lot when we started this project. That of course we can print out, as you told, you know, the furniture, different these flower pots, tables, which do not ask the special standard. Everything which is not the constructions which needs the strength to hold the whole house. Of course, we can do, and I think the next few years we will work with that one. For example, you can maybe do also some plaster. You can do the 3D printing and say that that's a plaster for the house, and you can fit that. 3D printing under the plaster standard.
Hmm.
This is somehow possible if because this plaster is just the like decorative thing.
Mm-hmm.
It's not holding any strength. Then of course I think it can be done. Of course, it always need to be approved by designers.
Mm-hmm.
But I think it can be done already.
Mm-hmm.
It's not that big deal, but
Yeah, we are doing it right now.
yeah,
Yes,
yeah,
yes.
it's true. But and
Mhm,
all those chairs and furnitures, yes, why not? We
mhm.
need to start with something.
So I think custom outdoor large scale furniture developers that use traditional methods that should start worrying because soon you will be able to go to depot buy a few.
Yes and no, because the next challenge is, I think you already saw that how heavy are those materials.
Mhm, mhm.
Even the not that big flower pot, I was not able to move. And if you print out the big furniture, I don't know, some wardrobe which you want to put in your living room or bedroom, but don't think that it's so easy to. You can buy it in a depot, but I don't know how you get it home
Mm-hmm.
by your own. You need I don't know, special tractor and from somebody. This will be the next step, and I think this is from our side. It's also not a problem. You can add the light fillers, the
Mm-hmm.
fillers, which is giving material is material can become 2 times lighter than it's normally.
Mm.
We have the materials. For example, if you do the cube and you put it in water, it flows on the
Ah.
top. It doesn't sink, so it's not a problem. And I think this is the next step where we will go with Riga's Technical University to try to print out something a little bit lighter. Of course, if it's lighter, it doesn't have so big strength. And yes,
Mm-hmm. For these lighter materials, I will definitely want to follow up on that question. For these currently usable, that actually probably works. Well, when we worked with the current material, we talked a lot with Maris with this weather durability, like will it perform like a standard concrete, or we have some risk of water freezing and the towing and breaking the benches. And currently, as I understand, we don't need to worry about if the material becomes lighter, which would be awesome for transporting the parts, because on-site printing, I think, is currently not that feasible, right?
yeah, with the printer which are not the on-site printer is not that easy at the moment, but I think in a future, later or sooner, as you saw,
That is a plan to do it on site.
yeah, on
Mhm.
site on site, because then, okay, you can print some small flower pot and move it, but if you print
Mhm.
something bigger, it's really heavy. And the what was the question? I
Oh yeah, I just
Super lift
that
you.
is a comment, and I didn't
Okay.
finish the question. Yeah, the question was about this on-site printing, where I wanted to lead it. That how far we currently are on that in Baltics. Do we have a solution that could work? Because right now it does feel like we are taking the concrete, transporting it to the laboratory, and then transporting it back the transporting to the site. So it's a lot of driving around, and also a lot of chances to damage the parts, or also having to split them in multiple prints, and all that in order to be able to fit in a lorry, or I just actually saw yesterday a video that I think they've transported in United States, a 4 meter sculpture they printed out, and it was really interesting that they put it on a lorry, like on a tourist sitting there, and but yeah, it's doable, of course, but renting a lorry is quite expensive, and then you so the question was how far we are with this. Do you see, like, are there already printers that are available for that, or they would need to be designed from anew? Is this something we can just try and implement in the Latvia or Baltics, or it's something that currently is being still in development and it's not something that we can do right now?
I in Baltics I haven't seen, at least nobody I haven't seen so far that there are those on-site printings. Of course, it's possible to do. We always need to remember about our weather conditions, so about that we can have the -20 in the winter and +30 in the summer, and then material reacts in different way. If you do such a printing, of course, in minuses you need to heat up, you need to cover from the rain, from the wind on the sides, from the rain on the top, and but what we need a printer in
Hmm.
Baltics to start to do that. And I haven't seen yet that somebody is doing that. I think the problem is that still it's kind of the only testing, and
Hmm.
like a Perry, for example, the
Yeah, I think
Perry is.
we need to trick them into getting one printer
Yeah,
because they could do
yeah,
it. Yeah.
yeah. That's true because I mean, okay, they done it in Germany, which is fine, and of course, as soon as they have more interest to do it in the Baltics, they can move the printer and do it there. But just we need to thought how to make them interested to do that.
Yeah, they are a little sponsored this time. I will try to interest them in building a building in Latvia. That would be great. Yeah, and then they also said that their printers work in this, also not covered the pro. Of course, not up to -20, but I think they said -5 or something like that. They managed to get it
Yeah, no,
working with.
-20, but -5 could be possible if you cover everything and you put these hot air blowers inside. Then it's possible, but then of course it's question about how much energy you spend to do that.
Oh yeah,
And
that's
you
true.
think maybe wait the spring, or the summer, not to do it in minuses.
I think we have one or two last questions. If someone wanted to really ask a question, you can raise your hand or write in the comments. And that's about the experimental materials you mentioned. One of them is getting the material lighter. Is there some else, other performance metrics you have looked on that you think would be of value for 3D printing market?
Yeah, the one thing is is lighter. The other thing is if you need to get it more flexible, let's say, because concrete as itself, it has some flexibility, but not that much. Then you can add also something to get it more flexible. Then depending of the printer and depending what you are printing out, of course, you need to think how fast it setting, how fast it becomes hard. Um, I think those are the most important. Of course, at a certain point, we will start to think about if it's necessary to improve some frost resistance. But I think these are the next steps. Mm.
Yeah, probably Matti is disconnected, but if he has some questions.
I think we will switch to, if Eva has a few minutes, we'll switch to like going to student ideas and maybe from this material slide.
Yeah, maybe Matti, I can give you my headphones because I really like. I think you have to. I don't see you on the list, but you see yourself. Yeah, I think we have some technical difficulties, but your Matti is disconnected. No, we are here. Good. No, you are not back. Because I see your screen, but your screen is maybe frozen. But yeah, if some maybe participants have something, you can write in chat or you can raise your hand. And yeah, we have still some minutes while Eva is here. And I will check Facebook as well. Maybe someone posted something. Yeah. Sorry about that. I will check. No, I think we don't have questions on Facebook. Mhm.
Sharing the live stream on Facebook parallelly with streaming on the computer leads to a crash. That's something we have discovered now. Anyhow, we thought that we have a few minutes to quickly go through the posters and see maybe Eva has some comments just from this material side. We already have tried some of the test prints in the concrete, and hopefully they will be also viewable either as photos or hopefully in real world in the competition on the 1st of April. But meanwhile, if the screen sharing will work, we will check, and maybe, as I understand, Deva, you already went through Miro. Yeah, and then if you have anything, we can just start alphabetically, but chronologically and go through. And if you have any comments for the submitted ideas, material-wise, or some advice on printing approaches, or just a comment from this material perspective, then that would be quite interesting. I think for this one, for example, a lighter material would be quite valuable. Can you see my screen?
Yes, yes,
Okay, yes.
yes,
Yeah, if
yes.
you have any
It's okay.
comment, you can say. If not, I will go to the
Okay.
next hand.
Yeah, of course. If we would, yes, I see.
Yeah, the thing was, if you have any comments from material perspective, you can tell the teams, or because they are preparing the presentations currently, and next week they will have a pitch training. And if there is something you think would be important to mention in the presentation for the jury from the materials side, if you have any suggestions or something that would be interested, we can add to that. Otherwise, the official part of the presentation has ended, and we can just have like this small after party where we non-formally go through the submitted works and just look at some suggestions for the presentation. One thing that Maris and or or at least it's not hearable in the live stream.
Okay.
We hear you perfectly.
Okay.
Andre will check if any microphones are on. I can quickly continue while Andre is switching off the microphone, that some of the suggestions we had already, or what we looked through at Mari's presentation, was different ways of covering the surface, like leaving it rough, or because that's what the teams, some of the teams already have a specific idea what they will do with the surface treatment, but otherwise maybe professionally, if you have some suggestion what your material would better work with, because there were some approaches where you just smoothen out the ridges while the material is wet. Some of the approaches were just leaving it rough and displaying it, and some of the approaches were plastering it over with something after the printing has finished, or adding some coating or painting it. But probably like this overarching question for each team or work is what you as a material producer would suggest as surface treatment approach in order to maybe prolong its life cycle or make it more durable for use.
Of course, the first thing it will be heavy. That's clear, and it will be done. It will be printed in parts. Of course, it would be possible to do that with a lighter material, but then of course, if we do also the bottom part with a lighter material, we need somebody need to do then the calculation if the bottom part with the lighter material will hold all the strength when you put it everything else on the top from the lighter material. That's only one my concern, but the other thing I think it can be done with the lighter material. The surface treatment, of course, if you glaze it, then you lose this 3D printing nice look, which I like a lot. You can do hydrophobization. There are special hydrophobizators, silicone ones, which you can put on the concrete surface, and it works as yeah, it doesn't absorb so much water and the dirt on the surface, which can help also from this frost resistance, because then the water wouldn't stay on some parts and doesn't that they didn't froze and broke the material in the end in spring. That can be the one thing what I can suggest.
Mhm. Okay, that's a really good comment. And I also think that for benches, for example, this rigid surface is something that probably when you sit, you feel it. But here, I think it visually works really well in that regard, that you really would want it to be rough. Like it's kind of like a fingerprint, like the skin also isn't silk smooth. I think it's really like a giant. Yeah, that's a great comment. So here's a team crazy idea for them. People will be, it's one of the only ideas where I understand people will be sitting directly on the concrete.
So the one thing, of course, in winter it will be cold, quite of cold. It will not be so comfortable than the wood bench outside, but it's okay. And of course, if the surface will be not smoothened, then some ice will definitely froze on those small holes, and then you need to sit on the ice in the winter if you do that in the winter, of course. That's the next question. But even if we smoothen out, you also can put some hydrophobizator on the top. Then it just doesn't absorb so much water. It reflects more water, and it's also the dirt, it doesn't become dirty so fast. Also, I think the next question will be the dirt. Also now outside when all the snow is melted, then there are a lot of sand flowing all around, and that sand then I think will be stuck on these on these holes, and then sooner or later some grass will start to grow up, which maybe is okay because
Will not be that
kind of
cold
the
anymore.
green. Yeah, but that could happen. If we talk about lighter material for this project, I'm not that sure. Maybe
It
on
can
some
be a bit
part.
heavy.
Yeah, maybe it will be heavy, maybe on some part where you put your back, but also because then there is a question, maybe some kids decides to, to jump all the way over, and then it can broke.
Here's the
Um,
estimated weight is 3.5 tons. I haven't
yeah,
asked how it was calculated, but oh, we do have a volume. Print volume is 40 cubic meters. That's a lot of material.
yeah, that's a lot of material.
And this one is 0.8 for comparison. And
Okay, that
I
makes
think it's completely filled in currently. We will have to. Daniela is here, right?
okay. Filled in.
Daniela, can you comment?
No.
I will check.
Yes, I'm not sure. Is it right
The number? Maybe
Because
it's 4
I
cubic
just
meters.
yes, I try to calculate this weight, but I'm not sure is it right because I'm just think that inside
The
parts.
formula could have messed up. I think you calculated this as full. I think Yuri Skljava could give you a more
Yeah,
specific
or you can
number.
write Juris and Maris, and maybe they can quickly take a look once again and just check before the presentations if it's okay.
Because what you need is infill percentage, how much of the volume is being infilled, and then you can calculate it by the total volume, and then you will get the actual volume of the print. Because this is the chair's volume, but I think the material volume is less because you are not infilling it fully. I don't think it's fully infilled. Very good that we checked that. So
Okay.
next is 4 a.m. Here we have 1,5. Yeah, I think these look like the real numbers.
Yeah,
So
yeah, the size looks the same at least, but visually.
yes.
Yeah, I think it's the same, but this is also something where you can sit and just chill
Yeah,
out.
and you have a wooden infill on top for this one. You can see
Okay,
here.
that's already sounds I think better. If you put the
Mhm.
wood on the top, it's also more comfortable when you sit. Of course, for the previous one, you can also maybe in the future to put kind of the heating inside, print inside some heating
Mm.
and
Put a solar panel or like this water that heats.
yeah, then put the solar panel and then which heats those electrical lines inside, or how do you call them. Then of course it's already something.
That's very interesting because heating the whole area would be impossible, but just heating the bench, we
Yeah,
always have thought about that. Like that's so great. And if you use solar energy, that's even more feasible. It's
yeah.
basically infinite. Like the only problem, you have to switch it off in summer.
I just do
Or
not know. Yeah, but probably. But
maybe in summer it's cooling, like it cools it
huh?
down.
Yeah, could be. No,
Yeah.
just don't know how much this solar battery is giving the energy in the winter time.
Yeah,
Because
that's a good question. Yeah.
have no idea about them.
We will have to talk with some engineers.
Because yeah. This is the same thing. Also, I think all the materials I would really suggest to cover with hydrophobizator, the silicone ones. It works like 2-3 years very successful. Maybe then you need to repeat again. Depending of what kind of to use it change or it doesn't change the surface. Some are making surface a little bit more shiny. Some it just sucking in the material and it doesn't make any shiny look. And they are all works quite good.
Mhm.
Um, yeah. Yeah. Also, um, I don't know how it will be when you put the plants in, and if you put it directly on the concrete, the sand for the flower pots, and then you start to put the water on the plants.
Mhm.
And if you put it too much, it can start to suck on the outside of this pot. You know what I mean?
Mhm.
Like in some
I
spots.
think they had a drainage system, but I think that's a very good comment. If they have to emphasize it in the presentation. So because from the poster, at least visually, it's hard to understand that there's a pot
Janis is
inside.
here. Maybe he
Hmm.
wants to say something from 4 a.m. Yeah. If you do, you want to
Or you
be
can, yeah, or you can have a cover this inside where you put the pots with some hydrophobizator. Then it doesn't allow the water flow inside because the concrete will suck the water for the pot for the plant for the flowers, and then yeah, to put inside the plastic maybe, and then the flower, then it's fine. Yeah, maybe you can do the comment how it's planned.
Yeah, Yanni, are you able to?
yeah, maybe he's not able, but all ours maybe can
Or
say
Tom's
something.
just unmuted
or-
himself.
Maybe I can answer.
Yeah.
Okay.
Sorry, could you please repeat the question?
The
About
question is about pots.
Yes, about this hydrophobic.
No. The idea was that we are worried that, or
Water
that Eva was worried that
drainage notika.
how
Yeah.
the drainage is planned. Will the water accumulate down there from the pots, or there is a way how to get?
Maybe
How
Lauris or Toms can answer.
how the greenery is being inserted.
Yeah, we have idea that we design flower pots, and there will be like they hanging in this. You can see in the isometric view there is a flower pots that you embed in the
These are the pots. Yeah, here
Yeah.
you can.
Okay, clear. Yeah,
Very good.
Yeah.
Yeah.
understood.
We will type a little thing. Lower pots.
Yeah.
This is not the printable version, but at least.
But those flower pots, they are the plastic ones, or they are also the concrete ones?
Yeah, we have different two ideas. That one idea is just we print from the plastic, and other idea we may make the CNC frame where you put inside the plastic, specially made plastic bag, and you can put those soil in those bags, and it stays still because there is this frame where this plastic bag is screwed in, and this frame.
Then it's okay. Yeah. Then it's fine. Then it's okay.
Okay, habitat is next.
Habitat. Can you go down? It's something to live in, or it's just as a...
This is for birds. So the idea is that
They
birds
had different visualizations before. Like they want the grass, they grow and
this
to
is the
get
theme that-
dirty, let's say.
I just like architect like for the view. I think I understood it.
It's basically designed from several parts that are connected, and the idea is that wildlife would live there inside. And I think they made all of the parts closed, so there are no holes. Yeah, you can see it here. It's just they are all like shelves.
I'm also about this, but the wildlife. Do you mean?
They want the birds to nest there.
The birds, for the birds.
Yes, it's a birdhouse. They'll get pooped on, but that's part of the.
But that's, I think, the part of the. In this case, of course, this everything which will come out from the birds, of course, will at a certain point will destroy the concrete. But if the birds are living there, I don't think that we need to. Okay, you can put some hydrophobizator, but then they start to leave. You cannot repeat this hydrophobization after the two,
And will
three.
it not make them sick, or it's completely harmless?
Yeah. No. It's okay. It's not a harmless. It's okay. This material, it's basically produced as a main material is a sand. It's pure silicium, but if they are living there, then you cannot reap the procedure after the 2 to 3 years. No, I don't know. I think in this case, it has to say that it is in a certain moment. It just collapse. I think maybe in 10, 20 years.
But that's probably part of this. If it does it inwards, I guess it can be interesting. At least it's not falling on everyone. It's like going inwards. Then maybe it's like a living structure, like a cliff that kind of lives its life.
Yeah, and also I think design is already some like a real thing, and if it destroys with the time a little bit, maybe
It will
just
look organic. Yeah.
yeah, it will look organic. It's not that bad.
Very interesting. Yeah, that's gonna be like built into the thing. Yeah, very good. Okay, the next team is architects, and here is their work. Originally, we were a little bit worried that water might seep in connectors, but I think they fixed it without. Yeah, they added this part, which yeah, okay. Now there are no parts where water could get inside.
Okay, I think the same about the flower pots. Need to think if you put the flowers in that the water need to drain out, and of course it's better if you do some 3D printing in the plastic and then put the pots in the plastic, because then otherwise this can not good. Then this water what go through the flower pots through the sun can make some spots on the concrete surface, which doesn't look so nice in the end. Also, the rest of the material, of course, which is not a wooden, can be treated with a hydrophobizator, just for the dirt stain and water repellency. Don't see nothing else to comment there. I think.
Okay.
Also, of course, the heavy. All
Mhm.
those things will be quite heavy.
Okay. Yeah, that's. Oh, I think it's not bad that it's heavy. It will not get stolen.
Yeah,
So,
hopefully. And also, it's not the metal which you can bring for some
yeah,
place to
exactly.
get the money. But
Mhm. So B98. This is also a pavilion.
mhm. they they will print it out like a small cubes, okay, and then they will put it together. I'm always worried how they will stick it to each other to get this cone.
They will use this structure steel frame that kind of connects
Okay,
them.
okay. That's okay.
Mhm.
Yeah, also can put some hydrophobizator for the longer life of the
We
product.
will do this as a blanket recommendation for
Yeah,
for all teams.
yeah, but it's yeah,
Is
it's
it made
really
by Socrates or there's
yeah. We can offer also something.
awesome? I mean, definitely we can do like half of this is hydrophobized and the other half isn't, and then we can compare.
Yes, this is
how,
what we always do. Yeah, this is what
perfect.
how we always also do the testing.
Mhm.
Um, yeah, I don't see nothing else there.
Yeah, I think it's the structural. It's the recommendations are similar as for the habitat theme. And the last but not the least currently is theme only. Oh no, there's free architecture too. Okay, we have one more. So this one is more horizontally printed
Hmm.
as a shelter from wind. I think this one is also one where we can expose the roughness of the material.
Yeah, this yeah, nice. I
Mhm.
like. But
Yeah.
also, yeah, no more additional comments about this
Yeah, I
one.
think for for the last themes there will be less comments because some of the
Yeah,
comments are,
they
are
they
general. Yeah,
repeat. Yes.
exactly. And this is the last theme, which have the only theme that actually does an overhang, but they do it's reinforced. But this one will be quite yeah.
How they do this on the
They
top?
reinforce it. I think they have a scheme how they connect them. There's a metal rod going inside. Currently in this poster, I can't see. They had some issues. Oh, here, like here you can see it's like very small, but it's designed from parts that come together, and there's a steel rod inside. But I
Okay.
think we do not have anyone from their team today. But in the presentation they will show, and then we can ask them.
Okay, then yeah, about about those constructional things, and
Yeah, of course.
I
For you,
am
it's
not
more
really there.
material wise. Like,
Yeah,
for
yeah,
example,
but
it will function as a roof here. So there would be a question would be like, do we need to protect it some specifically as when it's like a shelter type construction? But probably no, because it's still the same. Like the benches also get extended.
yeah, also the question is, as we do not know a lot about the material proper, or there is not written what kind of material properties we need to achieve. I really hope that the printed material will be enough dense to doesn't allow water to flow through. Because it can happen that the water flow if you have 3-hour autumn shower in Latvia, can happen. Of course, I don't know, but of course, if the water will
Very good comment. No one brought it up actually.
maybe not, but
Could be interesting to test it, definitely, like put it outside and see if it goes on someone's head.
yeah,
or it doesn't.
The first what you will see some wet spots on on the on the bottom, and then
part, yeah,
and then it will be start to drop some drops and tick tick tick, and yes, and your shelter is.
Yeah. Well, I would say a big thank you for the presentation. And then before we say goodbye, you can find the presentation here. If you have if you don't forgot something about the materials, it's available here. What else? Remember that next Tuesday for participants and for those who are watching it later, 29th of March, the same time as today at 7 o'clock, in person at university, we will be testing the equipment. Then you will be able to try the microphones, see how the presentation looks on the big screen. Also, it's important if the presentation works on your computers, because preferably you come to us, or if you want to use your computer, you have to test that it works with their system. So basically the next, you don't need to have the full team, but this is how it's like a general test or the final the final checkup. Also testing the print models, can they be put on tables, can they be assembled, etc. It would be nice if you can also bring your 3D prints. So we'll basically do a draft test of the exhibition too at that part. For teams who haven't yet submitted a VR model, that's the last part where we can actually do some testing. If you want to show it in virtual reality, as I know most of the teams will want to do that. If you haven't yet, that's the total deadline. And otherwise, see you all on 1st of April for the presentation. One more very important part, that all the lectures that have been recorded you can see here. And just even put the play button in the Miro board or open the YouTube link, and they are all recorded. So if you want to learn, for example, about preparing files for 3D concrete printing, or if you want to learn about 3D construction printing technology from our lecturer from Perry, it's all here. Also, all the review comments and everything, it's all saved and available as a playlist on our YouTube channel. Otherwise, thank you, Socrates, and thank you, Eva Zena. Virtual applauses, and hopefully see you all on the presentations.
Bye.
Bye.